talk about what the horizontal asymptotes are. So where are those horizontal asymptotes? Let's go to number 2, and let's define where our horizontal asymptotes are. Now, we need to copy down, let's copy down the function again. So we have 2x squared minus 12x plus 16 over x squared minus x minus 12. Now, with horizontal asymptotes, you do not need to factor the expressions in the top. So there is no factoring necessary to find the horizontal asymptotes. The key here is the beginning numbers, okay? The things we're going to do most often. So what we're going to look at is we are going to look at the highest degree term in the numerator, and we're going to look at the highest degree term in the denominator. So by looking at both of those things, we can now kind of determine where our horizontal asymptote is. So there are 3 different situations that we can talk about. Let's talk about this one, and then I'll talk about what it means to have the 2 other ones. So first of all, if you take 2x squared over x squared, you'll notice that these 2 things will cancel out. So as this graph, so what you know about this graph is as we approach the number 1, 2, the graphs will not cross that. So if we're coming from this side, we know that this will not cross here, and we will not cross 2. So your horizontal asymptote will be there. And there could be something going this way, and it will not cross 2 going that way. So we look at the highest degree term in both the numerator and the denominator, and we divide them. And then whatever value we get, that is where our horizontal asymptote is. Now, there are 2 other situations that we do need to discuss. What if we have an equation where you end up with, for example, x squared over, and the leading term in the bottom is like x cubed. Notice in both of these, this degree is higher. Where is the vertical asymptote going to be? The horizontal asymptote going to be? So in this situation, if that degree is higher, it will always go to 0, okay? So I want you to kind of think about this. If it's higher, so I want you to think about, if, let's just say I throw 100 in here, and I throw 100 in for x, but think about that. If you have 100 squared, it's going to be 10,000. If you have 100 cubed, it's going to be a lot bigger than that. So you're going to have a big number on the top, but you're going to have an even bigger number on the bottom. So what does that mean? This answer is going to be a fraction less than 1. Okay? So it is going to be less than 1. So it's going to keep getting smaller and smaller and smaller. Now, what happens on the other side? Okay? What if I take that same thing, except now I put the bigger exponent on the top. So the larger degree is up here. This one is higher. Okay? What is your horizontal asymptote? Your horizontal asymptote is there isn't any. Okay? Now I want you to think about that. What's going to happen? Well, as x keeps getting bigger and bigger and bigger, this number on the top is going to keep getting bigger and bigger and bigger compared to the bottom. So this is always going to just keep getting larger. So there is going to be no horizontal asymptote if the degree on the top is bigger than the degree on the bottom. Now, you'll notice in the middle here, the degree is the same. Okay? If they have the same degree, you'd need to divide them, and then whatever you get is going to be your horizontal asymptote. Okay? So, those are our key things. But what we're going to do now is we are going to draw or sketch a picture of this graph. Okay? And then we're going to review something called interval notation. So let's draw a few quick things. So let's make a graph. Let's put a few key features onto that graph. So first of all, let's just take what we just calculated. We know we have a horizontal asymptote at 2. So let's put a dotted line going through y equals 2. That's going to be your horizontal asymptote. Okay? Now, if we revert back to the problem before, our vertical asymptote was at the value of -3. Okay? And let's also value our hole was at 4. So let's go here. Let's sketch our graph. So let's put in a vertical asymptote, 1, at -3. So x equals -3 is my vertical asymptote. Now I also know that there is going to be at x equals 4, there is going to be a hole. But right now, I don't know where that hole is going to be. Okay? Because I don't know if the graph is going to be underneath or if it's going to be above. So my quick thing is I would kind of go this route. I would try to figure out where the line is going to be in terms of up here or down here on this side of the vertical asymptote. A very quick thing you can do is let's just plug 0 back into that function. So let's do 2 times 0 squared minus 12 times 0 over plus 16 over 0 squared minus 0 minus 12. Okay? Now, what did I just calculate? What I do know now is my y-intercept is -1.1 1/3, maybe, somewhere in there. So I know that my y-intercept is going to be somewhere down here. So what does that tell me about the graph? I know that this graph comes in from here, because we can't cross the vertical asymptote, and goes this way, and we can't cross 2. That means the hole is going to be right there. The hole is always on the graph. The hole is never down here on the x-axis. Okay? Now, if it's going this way, that means that up here, we're going to have the other portion of that graph. So this is going to be the graph of this function. Now, the final thing that I want to review with you is I want to show you, and it's actually something new. It's kind of old and it's kind of new. What you need to do is you need to know how the AP test is going to have you write the domain. Okay? So in this case, we need to review a couple things. When we write domain, okay, we use either brackets or we use parentheses. Okay? So let's just talk about the domain from here to x equals -3. Now remember, this part starts way over here at -infinity. And we're going to get all the way up to x equals 3. Now notice I'm using brackets, okay? These brackets mean not equal to. So we're going to go all the way up to 3, but x cannot equal 3, okay? Now, we are going to connect that, and this is called a union. This is how the AP test is going to say, we're going to have this part of our domain, which is going to go from negative infinity to 3. Then the next part of our domain is, it can't be 3, and it's going to go all the way up to 4. Oh, negative 3. I am sorry, I dropped my negative. It's going to go from negative 3 to 4, because at 4, we have a hole, and that doesn't exist. And then we are going to connect that to the part that's at the end. So it's going to go from 4, and then it continues all the way on to infinity. So it's going to go to positive infinity. So remember, if it's not equal to, you use parentheses. And in this problem, though, if it's equal to, I do want to tell you, if it's equal to, we use brackets. Okay? So if it can equal 3, this means equal to. If it can equal one of those numbers, then we use a bracket on that side. So there you go. This is my short video on reviewing how to find the key features of a rational function. Okay, so we reviewed how to do calculate holes, or the location of holes. We learned how to calculate where vertical asymptotes are. We reviewed how to do or calculate horizontal asymptotes as well. And then how do you sketch the graph from those things? So the new part is just reviewing or showing how the AP test writes out the domains of functions. So I hope this helps, and I will see you again on our next video.